Hi and welcome back. So over the past few videos we had been covering the electron configurations for elements in the S block, and then we figured out some configurations for elements over here in what we called the P block. And so now I think you're probably okay with figuring out electron configurations for elements over here in the P block, or at least figuring out the last entries for most elements over here in the P block. And I guess you could say that we were good up to, I guess maybe that point of figuring out the electron configurations for all the elements. We can figure out all the elements above this line, and we're still working on figuring out the electron configurations for everything below. So now let's actually start working on elements in the D block, and that'll actually hopefully give us a bit more of an insight into how to do complete electron configurations. So I'm going to actually clear off my drawing, and so now we're going to start talking about our D block. D block. So now let's just take an example. Let's say we were looking at titanium. So titanium is its atomic number is 22, and we're looking at the neutral atom. So we know that we need 22. We need 22 electrons around titanium. And so let's actually just start building up from the bottom. And this is actually the way that we're filling this, and you don't have to know this now. I'll definitely talk about this towards the end of the playlist, but essentially what we're doing by filling up electrons from the bottom is we're using the Aufbau principle, which is, it's German for to build up or from the bottom. I'm not too sure, but essentially what we're doing by starting with the lowest energy electrons, or the electrons that are going to spend most of their time closest to the nucleus, is essentially we're filling the electron orbitals using the Aufbau principle, if you need to know that. Anyway, and again, we'll definitely talk about that more in the future. So anyway, we're starting with our first, let me actually write in our periods again. 1, 2, 3, 4, 5, 6, 7. So we're going to start out with our first 1s orbital. So 1s, it's going to be full, 2s2. I'm going to go maybe a little bit faster than I should. Then we've got a completely full 2p orbital, so 2p6. And that's how many electrons it takes for a p orbital to be completely full, is 6 electrons. And then we're going to move on to our 3s orbital, so 3s2. Then we're going to move all the way over here, and we're going to have our 3p orbitals, so 3p orbitals. And our p orbitals are also going to be completely full, so we're going to have 6 orbitals full. Now we're going to come down to our 4s orbital, so 4s, and also this orbital is going to be completely full, so we're going to have 4s2. And now let's figure out how many electrons we've got. We've got 2 plus 2 is 6, and then also 2 plus 2 plus 6 is 10, plus 2 plus 2 plus 6 is 20. So far we've got 20 electrons. We've got, this is, we could say, an electron configuration that looks a lot like calcium. Calcium's right here. And we want to get to titanium, so we have to put in 2 more electrons. And titanium is what we were calling, it's in our D block. This is the D block right here. So we're going to start filling up our D orbitals, and you might be tempted right now to write in 4d2, but that is, it's just a little bit different. The D orbitals, they backfill 1 period. So actually this is going to be 3d2. So it's a little confusing, and maybe I'll do in the future a video that might I know on the Khan Academy, Sal did a video on giving you an intuitive sense of why you would backfill a period like that, or why we're in the fourth period. Why is the number on our d orbitals 3? And I'll maybe talk about that, about why that is in the future video. But essentially, right now, it's important to realize that that's essentially how we fill. We're going to backfill that period. So when we get to this point, after we reach the point where we have the same electron configuration as calcium, so after we write in 4s2, so we'd say right there, do that, we are going to backfill the next period. So we are going to backfill into our d orbitals. So how about, let's actually do another one of these. Let's say, what's a good one? How about, let's do iron. Iron, its atomic number is 26. So iron. And we are going to, it's going to have the exact same electron configuration as calcium up to that point. So we're going to say 1s2, 2s2, 2p6, 3s2, 3p6. This is just the exact same electron configuration up to that point that we wrote down. And then we're also going to have 4s2. So now we've got our same electron configuration as calcium. And now we just have to add on our 3d electrons. So our electrons that we're going to add on are going to be our 3d electrons. And we have got 1, 2, 3, 4, 5, 6 of them. So we are going to have 3d6. And this is going to be our electron configuration for iron. So anyway, that's essentially, I guess, how you would do the electron configurations. Let's actually do, real quick, let's do the full electron configuration for, let's say, germanium, element number 32. So essentially, we are going to need to fill up our d orbitals. And keep in mind, I'm going to go down to our d orbital chart. So if we said, and we can see that, I'll maybe talk a little bit more about all these weird shapes. I'll talk about these weird shapes that we have for our d orbitals later in the playlist in much more depth, because right now what we're essentially talking about in the playlist, or the concepts that we're essentially going over in the playlist, help us understand ions and help us understand really a bunch of other concepts. But as far as going over the specifics about how these orbitals are formed, we can, frankly, we can wait until, I guess, maybe the end of the playlist to get into the specifics about these shapes and everything. The important thing to realize right now is that, so if we took a look at our s orbital, we only have one s orbital in each period. So each s orbital only fits 2 electrons. It only fits, or I should say, we've got 2 electrons in each period. Our p orbitals, we had 3 different p orbitals. So we know that if we wanted to fill up a p orbital, or a full p orbital is going to be p6. And now let's take a look at our d orbitals right here. And so our d orbitals have got all these crazy shapes. And our d orbitals, we've got, the important thing to realize is that we have 5 of them. And remember, each orbital holds 2 electrons. So how many electrons can we fit into our d orbital, or how many electrons does it take to completely fill up our d orbital? Well, it takes 10, right? So if we had a full d orbital, our entry would be d10. It would be some period d10, okay? So that being said, let's go back up and take another look at this example we said, which is to do the electron configuration for germanium. And I'm actually going to do it down here in this little gap right here. So we're going to do the electron configuration for germanium. And we're just going to essentially copy down up to calcium's electron configuration, because it's going to be the same up to that point. So we had 1s2, 2s2, sorry, I'll draw that a bit better, 2s2, 2p6, 3s2, 3p6, 4s2. So now we've got the same configuration for calcium. And now we know that germanium is over here in our p block. So our last entry in our electron configuration is going to be some p orbital. So that means that our d orbital is going to be completely full. And you can also imagine, it's important to, I guess, maybe prove it to yourself that the d orbital is full by counting across and saying, we said that when a d orbital is full, we have got 10 electrons. So how wide is this d block? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got 10 different elements in this d block to completely fill up our d orbital. Okay? So we're going to have a completely full d orbital. And remember, we're still backfilling one principal number, one period number. So we're going to say 3d10. And then what's the last entry? Well, we're back on period 4, right? There's the p block is a bit easier to understand, I guess, than the d block in that regard. So we're back on period 4. And we're in the column where we know that our last entry is going to be whatever period we're on. So we're on the 4th period. And then P2, right? So our last entry is going to be, switch colors, is going to be 4P2. And let's add up all the electrons and just make sure that we're right. So we've got 2 plus 2 plus 6 is 10, plus 2 plus 6 plus 2 is 20, plus 10 gives us 30, and then plus another 2, that gives us what we want. We wanted 32 electrons, so we have 32 electrons. And this is, by the way, this is sometimes the shorthand I use to write an electron. I'll draw an E, a minus sign, and then a circle around it. So anyway, that would be the electron configuration for germanium. The important thing that hopefully I want you to take away from this video is that when we're working in this D block, so I'll outline the D block, when we're working in this block, or when we're working with our d orbitals, the period that we're in, so if we were working with elements that were in this 4th period, the period that we wrote down for our d orbital was our period minus 1. So if we were in the 4th period, we wrote down 3d. If we were in the 5th period, we wrote down 4d. If we were in the 6th period, we're going to write down 5d, etc., etc. In the next video, just because this is sort of where we start to get a bit more complex, maybe I'll do a few more examples for you, and hopefully it'll clear things up a bit. Anyway, thanks so much for watching, and I'll see you in a future video.